Oh, I need to bring this over here. Great. So here we are for some Ask a Physicist. So feel free to ask away. No, we weren't muted. We were just not muted. Just Mike was far away. That's all. Welcome, welcome. Glad everybody's here this morning. Apparently, and this is kind of like, I don't know if it's breaking news, but it's like a big deal. The UC school system has reported, has just released a report saying first-year students are far more unprepared for college today than they used to be. Like it's a problem. Like it's like a big problem. All right, well, why not we start with some questions? Is Mars flat? Mars is not flat. How do you ask a question? You type it into the chat box, and if I see it, and I think it's a valuable question, I will answer it. Effects from COVID, they blame COVID for at least part of it, but it's not clear that COVID is solely responsible. I haven't finished reading the report yet. How did the pyramids get built? By people and ingenuity. Yeah, so I haven't taught at the undergrad level in a few years, but I've spoken with my old professor, I've spoken with colleagues, and they have had similar experiences. Did you hydrate today? I did, but I'll hydrate again. Why is 0 not equal to 0? It is. We have that matter propagates like waves, but my understanding is waves must be propagated. How? I don't know what you mean by how. So waves propagate, that's what waves do. Waves don't need to be propagated. That's just like by being a wave, they are propagating. What actually is time? It's a good question. You got an UG because that's like a question, that's like an unsolved question. And it's also like half philosophy, half physics. Did I miss that Ask a Physicist change from Wednesday to Tuesdays? No, it's on both days because it's fairly popular and people like it. People like it a lot. And I like doing it. Math versus physics, with math being self-referential and complete in the basis of physics. I don't understand what the question is. Do your Patreon notes have information on so-called quantum consciousness? Nope, I don't do that debate because it's really boring. Actually, maybe it does. Let me double check. It might actually. Well, it has stuff about the double slit, but just one link, so. Do you play Kerbal Space Program? I haven't in a long time, but I did put many hours into it when I was an undergrad. If I have an empty box, is there anything in it? It depends on what you mean by anything. Like, there's always quantum fields everywhere. So yeah. Could there be structures in space outside our field of view? Yeah, sure, absolutely. I mean, like, that's probably what the Great Attractor is. The Great Attractor is on the other side. So we're at one place in the galaxy. Your galaxy is a big, thick disk. We're over here. The Great Attractor is somewhere in this direction. So, like, our galaxy's in the way. We can't see it. It's probably just a whole bunch of galaxies, though. How do you argue against people who think everything is frequencies? Just ask them to define what a frequency is, and if they offer a definition, or if they don't, just tell them that a frequency is the rate at which something oscillates, and then you just have to ask them what's the thing doing the oscillation. What is in a vacuum space? I find it hard to believe there's literally nothing. Well, look, there are quantum fields everywhere, but quantum fields can be in a vacuum state, which is kind of what we would call empty. But even like setting aside like the quantum fields, for every, depends on where you are in space, but it's something like every cubic centimeter, you have like one particle. Infinite regress year night, it seems fine. Are there any other sandbox physics games that you've played a lot of? Or Factorio isn't really a physics game, but that game's like, we call it Cracktorio for a reason. Are there any decent theories that could break one of the 4 laws of physics? I don't know what 4 laws of physics you're referring to. What are quantum fields? I'm a dummy. So look, quantum fields are just quantum fields, you can think of them as like It's really hard to explain. In some sense, they're fundamental. They are properties of space-time that account for the ways that particles behave and the way that forces behave. Newton's laws, there are like 4 major laws. Well, so there's Newton's 3 laws of motion, then there's Newton's law of gravitation, but then there's like so many other laws. Are you a theoretical physicist? Sort of. I usually use the word mathematical physicist because I do more mathematics than a theoretical physicist does, or perhaps I do it in a different way. Can you explain the hierarchy problem? Yeah, so the hierarchy problem is roughly the idea that like we have a bunch of stuff that happens at low energies, like the mass of a proton is like 1 giga-electron-volt or so, and like there's a whole bunch of like bound states of stuff that happens at around that energy level. And then you can keep adding energy and you get a whole bunch of more particles that come out, and you can build more and more complicated particles that decay faster and faster and so on. And then you get up to like around the 150 to 200 GeV level, so about 100 to 200 times the mass of the proton. And what you end up with is that's where you see the Higgs boson. The Higgs boson has a mass of 125 GeV or so. The thing is so it seems like all of the interesting physics happens between like 1G, all of the interesting strong and weak, strong physics anyway. Well, I shouldn't say all of the interesting standard model physics seems like it happens like below 250 GeV, say. But the place where we expect unification to happen is at like 10 to the 16 GeV. And so there's just like a really big gap between where the physics happens, and then there's just like a big swath of nothing for like many orders of magnitudes. And so like there seems to be like a weird hierarchy of masses that just aren't arranged in a natural way. That's the idea anyway. Can you explain why the LIGO experiment failed to measure gravity? They didn't. The LIGO experiment explicitly measured gravitational waves. That's what LIGO experiment did. Grimlock sends $5 for saw the bald lightning video. Loved it. Have you hydrated? Okay, I'll hydrate again. But I have hydrated, yeah. Would you advise Star Trek if asked? Oh, absolutely. 100% absolutely. That would be such an honor. Wasn't there a recent paper just out saying the acceleration isn't happening? Yeah, it's a big deal. Yeah, it's a big deal. We'll see if it holds up, because you know, even if a paper is peer reviewed, which it was, that doesn't mean that it's you know, free of scrutiny. So we'll see if people basically prove it wrong, but it's a big deal. Can you have a particle made of quarks whose charges are non-standard, like with a charge equal to 1.5 or something? I don't think so. So yeah, what would that entail? So you could have, so like for example, if you had two up, yeah. So the trouble is whenever you want a stable hadron, whenever you want a stable hadron, it has to have at least one of the, okay. Let me phrase this properly. Oops. So stable hadrons, as far as we can tell, have either 2 up types. So there's baryons, which have three quarks, which have either 2 up types and 1 down type, 3 up types, 1 up type and 2 down types, or you know, the same across down types. But it'll never just be 2 up types. That would be a meson. Mesons are 2 quarks. And if you had 2 up types, then you just don't get a stable baryon. You need an up type and an anti-down type, or a down type or something like this, to get a stable meson. And similarly, the same seems to be the case for tetraquarks and pentaquarks and so on. So no, it seems like everything is always quantized in single units. Now, I'd actually have to think some more about why that's the case, but like I've looked at all of the particle database, and all of the particles that we've ever synthesized, that we've ever built do have this property. I'd have to think about why that's the case. There's probably a super selection rule involved. Could hyperbolic manifolds permit wormhole topologies without violating Lorentz invariance? So if by hyperbolic manifolds you mean like space-times with negative negative scalar curvature, I guess in principle they could. You could have a non-simply connected, yeah, of course. You could have a non-simply connected negative scalar curvature manifold. That would be like a for like a torus with several holes, for example, that's in 4 dimensions, so that's fine. You could absolutely have that. James P. Pesh sends $2. Is there a value to linguistic and visual models, i.e. geometric unity? Well, if that's what you mean by GU. So geometric unity is not taken seriously by anybody. But generally, no. Visual models can be helpful for your intuition, but linguistic and visual models are not really how we build theoretical models these days. And it hasn't really been that way for like 150 years. Or maybe even longer. How do we know that singularities inside black holes exist when we can't measure it? We don't know that singularities inside black holes exist. In fact, I don't think that they do exist. It's just one of these things where it's like, it's a prediction of the general relativity that singularities would exist. But that assumes that there's nothing quantum happening at the quantum level inside of a black hole. And we would expect that quantum stuff would happen, which would change what we understand the physics to do. Would love to hear your thoughts on Sir Roger Penrose's CCC theory. So from an aesthetic point of view and a personal point of view, I would love CCC to be true. This is conformal cyclic cosmology. However, it seems like there's just not really good evidence supporting it. And in fact, I know that Penrose disagrees, but I've seen that there's evidence against it. So what is a physicist? Is that study of space or physics? A physicist is somebody who studies physics. Somebody who does research in physics, if you will. John the Maven sends $5. By the way, if you want your question answered with priority, send a super chat. It's a good way to do it. Can you explain supergravity and supersymmetry for a layperson to help me win an anime debate in under 5 minutes? Probably not. I don't know supergravity that well. I know supergravity is what happens when you have supersymmetry plus gravity, but I don't know much more than that. Supersymmetry, on the other hand, I do have a video on. Supersymmetry is merely the idea that for every type of... There are basically 2 kinds of fundamental particles. There's fermions, which are particles with half-integer spin. You could kind of think of them as the kinds of particles that take up space. And they make up what you might call matter. And then there's the bosons. These are things like the force particles and the Higgs boson. These don't really take up space, but they change the features of the fermions. They cause forces, they cause masses, and so on. So what supersymmetry says is that for every fundamental particle, there's a second fundamental particle that is of the opposite kind. So if you have an electron, which is a fundamental particle, and that's a fermion, then there is something called a selectron. Silly name, but it's the supersymmetric partner of the electron, and in this case it would have full integer spin, meaning it's a boson, and so it would either be a scalar or it would be a vector. I don't actually remember what the selectron is supposed to be. Let's find out. A selectron is supposed to be what's the spin of a selectron? Spin 0, so they're supposed to be scalars. And for example, you would also have a photon, and you'd have the photino, which is great, which would be spin 1/2. That is the supersymmetric partner of the photon. So, physicists are clever and fun with their names. Or particle physicists are, anyway. 2 scalars, yeah, okay. So I guess that there'd be 2, yeah, of course there'd have to be 2 scalars so that the degrees of freedom match up, sure. Jorge with the win. Jorge did supersymmetric dark matter stuff for his PhD, if I remember correctly. Can you explain residual versus strong normal force? So the rough idea is that the strong normal force you might call the color force. And so you have 3 different kinds of charge, right? So you have red, green, and blue charge, and then you have anti-red, anti-green, and anti-blue charge. And so red attracts anti-red, blue attracts anti-blue, green attracts anti-green, sort of. And also red attracts green and blue, blue attracts green and red, and so on, so that they kind of attract the colors attract each other, so that you end up with nothing, or with all the colors canceling out. Fine. So that's the normal strong force. The thing is the strong force is so strong that any overall color charge always finds a partner to cancel out. So you will never see a bare color charge in the wild, unlike with electromagnetism, where you will absolutely see bare electric charges in the wild. You can just go find an electron, right? You will never see a bare color charge in the wild. However, once you have these bound states which have neutral color charge, white, you might call it white or something like this, like red, green, and blue together all make white. If you have 2 bound states that have neutral color charge, well, they still have color charge inside of them, kind of like going around in different directions, moving around from the quarks, and so that you can get like a colored dipole kind of thing. And so essentially you can get like a sort of residual effect, not from charge attracting charge, but from a distribution of charge attracting a distribution of charge. That's the rough idea. Do you have a paper that oh, this is $5 from Theosophical Wanderings. Do you have a paper that shows how the cosmological constant was solved? Yeah, actually. In fact, another one just appeared on the archive, but there's a paper by Steve Carlip. Let me just make sure that I remember what the title is. There's a paper by Steve Carlip from 2019 called Hiding the Cosmological Constant. There's another paper called, this is by Wang and Unra, I think. It's by Qingdi Wang. This is from 2023, I want to say. Sorry, it's loading. I'm just... That shows that the yeah, okay, so no, that's the wrong one. I know it's a recent paper by Qingdi Wang, but anyway, there's a paper by Qingdi Wang that's from like 2023 or 2022 or something like this, that kind of implements the idea that Steve Carlip was talking about in 2019. And then I wrote a paper that I'm not going to tell you my name, but I wrote a paper talking about kind of examining the microscopic quantum gravitational details of how this works in a toy model. So between those three papers, I generally consider it solved. Now, you know, a lot of people might disagree, but I think that this is like generally not a problem anymore. Now, NFT Vegeta sends 70 ZAR, which I don't know what that is, but I appreciate the super chat nonetheless. It's about $4. They ask, I'm curious, is it more likely that the universe came from nothing, or more likely that there was a creator that's not bound by the laws of physics because he created the reality as we know it? I don't think that either are likely. I don't think that there ever was nothing. I think that in some sense, I think that the universe has existed for every moment of time, and I think that the universe existed timelessly when there was no time. Or if there was no time. How can you be sure the Earth isn't shaped like a triangle? Because we have pictures. I can't believe you remember all the article authors. I would be nothing without Zotero. Well, so Steve Carlip is somebody I happen to know personally, and Qingdi Wang was not. I didn't remember his first name. I remembered his last name, but his article, he was a student of what's his name, Paul Unruh, and Paul Unruh is pretty famous, and so they wrote a paper together about this. No, it's not Paul Unruh. Anyway, so it just happens to be that I've remembered their names. I usually don't. What do we miss to prove string theory? Well, look, the thing is we just need experimental data. That's what it boils down to, and that's very, very long way away. How is it possible that you move slower in time the closer you are to the speed of light? Well, you're asking how is it possible? The laws of physics say that that's what happens. So it's possible because that's what the laws of physics are. Now, if you're asking why, like what's some intuition as to why that should be the case? Well, one of the fundamental postulates of special relativity is that the speed of light is the same regardless of who's measuring it. You will always measure the speed of light to be the same. And so a consequence of this is that if you have a light clock, which you basically just have a beam of light bouncing between two mirrors, and you basically have one tick of the clock occur for every time it reaches, say, the top mirror again. If you're holding the light clock will appear to, it'll take a certain amount of time from your perspective to tick between the two mirrors. But if you're moving from somebody else's perspective, that light has to bounce a further distance because it has to move at an angle, and so it'll take longer. And so the amount of time between ticks from your perspective is longer from their perspective, so they will see your clock move slower. That's roughly the idea. That's the intuition. And in fact, I think that's the intuition that Einstein used too. Why does the moon glow and reflect light? Everything glows and reflects light except black holes, basically. Do you think ball lightning can be made? I mean, sort of. Watch the video. Please explain the n-body problem and why it's unsolvable. It's not unsolvable. We just can use numerics to solve it. There aren't analytic solutions because, you can prove that there are no first integrals for that kind of system. But yeah, you absolutely can solve the three-body problem. You can actually solve the n-body problem. It just, it just takes a lot of computational power. Why does light appear to move faster in one direction? It doesn't. It's proven to be unsolvable? No, in fact, Sundman back in the early 1900s proved that there is a solution, and he gave a solution. James Pesh, again, with the $5. Thank you so much. Which brute facts in current models are fundamental, and do 720-degree spinners solve any string theory inconsistencies? So superstring theory already includes half integer spin fermions, so like there's no issue there. That's already part of string theory. In fact, that's why string theory has 10 dimensions rather than 26. Superstring theory includes fermions. Which brute facts are in current models are fundamental? I mean, we generally treat constants as fundamental and brute, but that doesn't mean that doesn't mean that they always will be. It's just that we assume that they are until we have better evidence otherwise. Yeah. Michio Kaku is one of my favorite theoretical physicists. Can you suggest me other books? Or don't read Michio Kaku anymore. The dude is off his rocker. Unfortunately, he used to be really, really good, but now he's kind of just the go-to physicist, and he just spouts stuff that's very unproven and very, very speculative. Is it feasible to think micro black holes are what make up dark matter? Yeah, this is a thing that people take seriously. They're called primordial black holes. You can look at primordial black hole dark matter, and people absolutely consider it and are trying to either prove it or rule it out. How close is the current theoretical physics community a true unified field model that includes not just forces but information flow? Well, a unified field, like a unified field theory, would not include information flow. That's not like part of what a unified field theory is. A unified field theory would describe the unification of the weak nuclear force, the strong nuclear force, and electromagnetism. And generally, that's kind of fallen out of favor. Like it's not clear that that's a thing that even exists anymore, or it's not even clear that we should expect such a thing to exist. Do you know physics? Yes, I do. Can you explain how we are conscious if we are made of just atoms? Ask neurologists or something. That's not a physics question. If we travel near the speed of light, would we have to account for different regions of time dilation? I don't know what you mean by different regions. In special relativity, again, this is special relativity, not general relativity, but in special relativity, if you're traveling at the speed of light, then all of you is traveling at the speed of light, and so you will all of you will experience the same amount of time dilation. Tim for Pele asks, with $5, thank you, what properties would a 3 + 2, 3 space dimensions, 2 time dimensions universe have? How would causality and movement between reference frames behave? Oh, so I suspect, and I haven't proven this, I haven't read the papers that prove this, but I suspect that such a universe would just be causally unstable. Things could move back in time. You wouldn't be able to have globally hyperbolic spacetimes. You wouldn't be able to predict the outcomes of you wouldn't be able to predict the outcomes of even a classical system given some initial state. That you would be basically not, you basically wouldn't be able to do any physics, because you would be able to move around in time, backwards, forwards, all sorts of things. I meant different regions of time dilation in space you'll be moving through. So that's not really, so time dilation, so there's gravitational time dilation, and then there's, special relativistic time dilation. These are kind of two separate things. The trouble is that you just don't worry about special relativistic time dilation once you're in a general relativistic setting. You just, the special relativity piece is subsumed by the general relativity. And so, yeah, I mean, it's like, if you're moving through space, the rate at which time flows for you will depend on what's going on around you, how fast you're moving, what are the gravitational fields, and so on. And if you wanted to like reset your clock after you're done traveling, then yeah, you would need to keep track of all of that. James Pesh again with the $5 asks, forgive my ignorance rather than get lost in Google searches. What are the constants in contemporary models that are brute facts? All of the physical constants, right? They're generally thought of as brute facts, or they're perhaps thought of as emergent, but we don't know what they emerge from. So for example, the ratio of the up quark mass to the down quark, in fact, all of the masses of the quarks would be thought of as kind of like just brute facts that you just have to measure. You can't like derive them from deeper principles. The Higgs vacuum expectation value would be an example. Probably not the Hubble constant. Yeah, so it's probably those guys, and really you would want to have unitless things. So you would want to like divide all of these masses by the Higgs vev or something like this, and these would be underivable quantities, at least as far as we can tell. So if you look up standard model particle physics constants, you'll find like a list of like 19 numbers or something like this, or 26 numbers or whatever the number is, and those are the constants that we treat. I mean, physicists don't think of them as like brute facts, Physicists just think of them as constants. They're just parts of nature. Now, if you ask a philosopher, is that a brute fact? They'll probably say yeah. Do you think the universe is more accurately described as computational vibration beyond those? I don't think it's any of those. Do black holes have negative or infinite energy? No. Did the Big Bang expansion move faster than the speed of light? And if so, expansions don't have speeds, right? Think of expansions as like doubling times. So if you take a sheet of paper and you double its size, how would you say what speed it was expanding at? Like, expansions don't have speeds, right? As far as we can tell, the universe doesn't have an edge, so it's not like the edges are moving. It's like the whole thing is getting bigger. Nothing is brute fact. Everything is relative to our ability to perceive. Okay. Thoughts on dark energy or matter? Yeah, so dark matter, probably just some stuff that we can't see. It's either tiny black holes or it's some particle that we haven't detected yet. Dark energy, though, is way less certain about what that could be. Change in area over time measures expansion. No, so it's the way that we measure expansion is with a you can measure it with like a unitless quantity. So you take the rate of change of, so you take a volume, you take the rate of change of the volume, you divide it by the volume, and that will give you the expansion rate. What is charge, and why do quarks have fractional charge? Don't we measure charge in terms of number of protons and neutrons? So what is charge? Charge is a fundamental property of matter, right? So things can have mass, things can also have charge. It's just like a thing that particles can have. It's not like, it's hard to say that it's much deeper than that. Kind of the way that we talk about particles is particles are what you would say, like mathematically the way that we talk about particles is they are irreducible representations of certain symmetry groups. And one of those symmetry groups is the symmetry group corresponding to electromagnetism. And so if you're in the trivial representation of the electromagnetic symmetry group, then you have zero charge. If you're in the non-trivial representation, then you have non-zero charge. There's not like, and beyond that, beyond saying that like charge is a result of the symmetry of electromagnetism, there's just not really an explanation. It's just the thing that particles have. Now, as far as what charge is, we measure charge not only in terms of protons and neutrons, we measure charge in terms of coulombs, right? Or in terms of the fundamental charge being the charge of an electron. Now, why quarks have fractional charge? They just do. It's just a property that quarks have. By the way, and I should just mention this just while I have a minute. So there are currently 3 streams that I'm talking to. There's TikTok, there's a vertical YouTube stream, and a horizontal YouTube stream. So if you like horizontal, you should go to YouTube, go to the Dr. Blitz Debunks page, go watch there. Also, if you haven't already subscribed to the Dr. Blitz Debunks page, you should. And the reason I say that is because that page is struggling to get subscribers because I'm just really not advertising it as much as I advertise the original channel. So make sure to go do that. I have clips from debates there. I have some shorts there as well that are debunking shorts. So that's a good place to see that kind of thing. Why doesn't your mouth match your speech? Oh, that I can't answer for you. I don't know. What do you think about Penrose's quantum consciousness? I think that he is a little bit, we give him leeway because he's very, very brilliant, but I think he's just super wrong about that. From Serial Dude, we have with the $2. Is there a different observable universe for each observable? Yeah, but like barely. How did Michelson-Morley lead Einstein's relativity? It's actually not clear from a historical perspective if Einstein views the Michelson-Morley experiment as like laying the groundwork for relativity. Like that's kind of like the pop science story that's told, that like, oh, the Michelson-Morley experiment put into question the ether, and then Einstein came along and said, the Michelson-Morley experiment, we can use this. But it's actually not clear that that's what happened, right? If you go read the writings of Einstein, on the one hand, he will give all of the credit to Michelson and Morley, and then 5 years later, he will say, yeah, like as much as people like to say it, it didn't really have a significant impact on the development of the theory. So it's just not clear that that's like a real thing that happened, like historically. Why the Discord link never works for me? Because you're probably just clicking on it. You have to copy and paste the link into a browser. Why is water not considered a good lubricant if things get slippery when wet? I don't know. That's a material science question. How many more years do we have before the Earth explodes? The Earth's not going to explode. What size is a force? That's a category error. Forces don't have size. Is the universe a closed, open, or isolated system? It depends on how you're defining these things, but likely these terms are just not well defined for the universe as a whole, because usually we use these terms in relation to a system relative to its environment. But there is no environment outside of the universe, right? That's kind of definitionally the case. So it's probably just not well defined. Now, Nectu sends $6.66. Can you please critique Eternal Return? Maybe you did and I missed it. I'm a fan of Eternal Return. I'd like to know where you find any issues with it. I don't know what Eternal Return is. I don't know if it's like... That's a philosophical concept, which states that time repeats itself in an infinite loop and that exactly the same events will continue to occur in exactly the same way over and over again for eternity. I don't have any issues with it. It seems at least... Like, I don't know how we would rule it out. It seems at least possible. Now, I mean, of course, there are like entropic critiques, but these are entropic critiques that apply to any cyclic cosmology. Whether or not whether or not each cycle is identical to the last kind of is irrelevant to whether or not you can make an entropic critique. It's a time cube. Indeed, it's a time cube. Yeah, verts believe in objective morality. Yeah, you horizontals, I guess you only believe in subjective morality. Dr. Blitz, you dabble in string theory. Does your work in differential geometry include theoretical extra dimensions? I don't really mess with string theory at all. But yes, my work in differential geometry does involve like I just proved a theorem yesterday, or it was a lemma really, about it was about manifolds in eight or more even dimensions, or 8 or more dimensions that are even. So the dimension is 8, 10, 12, whatever. So yeah, like that, I do that all the time. Have you published? Yeah, like more than a dozen times in the last 5 years. How do physicists know what events will occur in the world in billions, millions of years from now? Well, look, so the whole business of physics is being able to look at regularities in nature, and assuming those regularities hold in the future, you can then extrapolate what will happen in the future by following such and such laws. That's roughly the idea. I mean, if you throw a baseball, you can predict what path it'll take before you throw it using the laws of physics. Is there any info contained in Hawking radiation and how would it be decoded? So generally it's believed that there is info contained in Hawking radiation. Nobody has any idea how it would be decoded, because the actual details of like how the Hawking radiation is emitted, that is quantum gravity stuff. It's not clear like what the actual distribution of information is. How do we know that photons change their state when we start observing them? How would we know their state before starting the observation to compare? Well, they don't change their state when you start observing them. They just behave. They just interact with us, and by interacting with us, they, well, okay. So in some sense, they do, I guess. By interacting with something, it changes the way that thing behaves for obvious reasons. Like imagine that you were trying to measure what angle a car window was at by throwing a baseball at it and seeing what angle it bounced off. Well, by throwing a baseball at a car window, you're going to break the car window. So like anytime you try to interact with something, you're going to change the way it behaves. Now, the reason why we know that they behaved differently beforehand is because we can see how they behave if we leave them alone and then just let them hit the screen, and we'll see an interference pattern. Or you can interfere with them, you can interact with them. You can make that witch path information available in the double slit experiment, for example, and you will see that interference pattern disappears. And so like you can definitely see two different observable phenomena, and it's because of that interaction, essentially because you are entangling yourself with the photon when you get the witch slit information. Flat earther claims rockets cannot travel in space, a substance required for propulsion to occur. Yes, flat earthers are wrong. What is the most interesting thing in physics for you, or what do you like to study? So black holes and the early universe are the things that I like the most. Is mathematical physics nowadays called computational physics? No, they're very different. Computational physics is very much doing simulations and stuff. That's not what I do. Tim for Pele asks a $5 question. Thank you so much. This is likely beyond a question for live, but could you explain Twistor theory a bit? From my initial reading, it almost seems like a correspondence. No, I can't. It's been on my bucket list to learn how Twistor theory works for like the longest time. Even so much that I went to a conference where Roger Penrose was speaking in fall of 23 with the intent of learning how twistors work, and I still don't understand them. So no, I wish I could, but I can't. Dr. Blitz, I was watching Sabina Hossenfelder. Is the dark and dark energy just the value of something that's unknown? It's called dark energy because if you plug in some energy source that has certain properties, it makes the universe behave the way we expect it to behave. But we have no idea what's causing that energy source. And so it's called dark energy because, you know, it's like you can't see it, right? You don't know what it is. Isn't the fine-tuning argument dead on arrival? Wait a minute. Dead on arrival until it can be demonstrated that any constant was or could have been different than what it was? Yeah, absolutely. That's my general critique of the fine-tuning argument. Yes. Do you know why light doesn't speed up or slow down relative to a moving observer? It's a law of physics. I mean, it's just a law of physics. It's the way our universe is. The questions of why, I mean, I could give you like mathematical explanations and be like, oh, we live in a Lorentzian manifold and the Lorentzian manifold has Lorentz symmetry, like all of this stuff, but that's not going to be useful. It won't give you any more depth, right? I have a thermal physics exam soon. Do you have any useful intuition for chemical potential? Not really. The best I have is that chemical potential basically tells you about like how much particles want to enter or leave of different species, but I don't really, like that's one of the things I struggled with when I was learning thermal physics as well. Can you explain why what's in motion tends to stay in motion, vice versa, that's saying? Yeah, so that's Newton's first law of motion. An object in motion stays in motion unless acted upon by an external force. An object at rest stays at rest unless acted upon by an external force. And it's basic, like I don't know, it seems like obvious. I don't know why he got so much kudos for this. Like, haha, an object won't move unless you move it. Haha, an object won't turn unless you turn it. Like, of course that's how it works. But, you know, how much do you study and what method do you use? I'm not a student, so I don't really study in the way that you might think I do. I always have a hard time understanding moving at the speed of light on a photon and then jumping forward, but being incapable of going faster than the speed of light. Well, you can't move on a photon, right? You can't move at the speed of light on a photon. And you also can't jump forward. Like, you can't exist moving at the speed of light. You wouldn't be you. Are you just repeating what you learned? Like, have you seen an electron or neutron to know it really exists? I mean, I've seen pictures, like actual photographs from these things, but in a certain, I mean, like, if by learn you mean like having conducted my own research, having done my own experiments, that's like one way of learning. And so, yeah. I also learned some things in lectures. I learned some things by reading research papers. I learned some things by doing experiments. I learned some things by, like, you learn things in a whole bunch of different ways. I don't understand like the anti-intellectual. Oh, you just learned stuff. What a nerd. Learn, like, what? I don't understand that at all. Is it humanly possible to jump when an elevator is falling and survive? Well, you probably won't survive, but you can jump. What's the best way for professors to teach mathematical physics to second-year undergrads? I don't know what a mathematical physics looks like for second-year undergrads. Why are photons shaped like lemons? They're not. Who said that they're shaped like lemons? At least I haven't heard about this. Do you ever get overwhelmed or emotional when you ponder the universe? Not really. Quick answer, why flat earthers wrong claiming substance required in space for propulsion? Oh, because you can just do an experiment and you see that like rocket engines work in a vacuum. Alternatively, you could just say that Newton's third law is that every action has an equal and opposite reaction. And so if you push something out the back, it pushes you forward. Yeah, this is just like the most brain dead flat earth take I've ever heard. But a lot of them make it. Why can we head into the future with the speed of light but not backward? Well, you can't go the speed of light. But you can head into the future. So one way that I like to think about why we can go forward in time but not backwards is because, like, imagine that you were on a track, right? You were on like a roller coaster that only goes forward. Now, you could speed up or slow down. There's no issue there. But you can't turn around, right? If your wheels only turn one way, in order to go backwards, you'd have to turn the roller coaster around, but you can't do that because there's just not enough dimensions of time to turn in. There's only one dimension of time, so you can't turn. Doesn't time moving forward have to do with entropy? That's one idea. It's probably the most prominent idea, yeah. Why does going close to the speed of light if we could slow down time for whoever is going fast? Yeah, so roughly, it's because light always must travel at the same speed regardless of who's looking at it. And so if you can measure time by setting up a light clock, and so the light clock will have to, like light bouncing between two mirrors. If you're moving relative to somebody else, from their perspective, the ticks of your light clock will take longer because there's a bigger gap, because not only is it bouncing up and down, it's also moving side to side. That's one way to think about it. J. Owen Full with the $5. Thank you. I define moving inward in the size dimension as the direction of travel such that as you approach an electron, it appears to get bigger. Can I email you? I mean, I have there's like a form that you can fill out on my link tree, but I don't know what this question means. Can a gravitational wave move faster than light? Can't we ride a gravitational wave? No, gravitational waves move at the speed of light. How is the universe expanding faster than the speed of light? It's not. This is not a thing. There are no edges that are growing faster than the speed of light. The expansion rate is, it's like a doubling size. It's not like a speed. Joe Mac, thank you for the hanging lights. I appreciate that. Do you think the graviton is real? Yeah, kinda. Is an expansion slowing? Well, at least according to a recent paper, that's the case, but we just don't know. Like this is still very much frontier science, and we should temper our expectations. Since the universe is expanding, does that mean that there's more dark energy than dark matter? It's hard to compare them. Generally, the view is that yes, there is more dark energy. Like the total energy amount of dark energy is less, or is more than the total energy amount of dark matter. That's generally the view, yeah. What is cubism or quantum Bayesianism? I'm not so familiar with it. It's an interpretation of quantum mechanics that basically says that the wave function's probabilities is about our knowledge of it. It's not about anything that actually is happening on the ground. If electromagnetism is the bottleneck for causality, can we locally change its speed to move faster than light? You're asking, can we locally change the laws of physics to break the laws of physics? I mean, no, they're laws of physics for a reason, right? Like if you could break them, they wouldn't be laws. Do you accept the axiom of choice? I mean, like it's usually irrelevant for the kind of work that I do, but I think it's like kind of reasonable sometimes. And then other times I think it's super unreasonable when I think about Banach-Tarski. Who is the most important physicist alive? That's a really good question. I don't know if there is one. I don't know if that's a thing that exists in this day and age. Can you expand on the concept of space expanding in a simple way? Yeah, so imagine they got a spreadsheet, like in Excel. The spreadsheet, in principle, goes on forever. Like you could go to the right forever, you could go down forever. Now imagine that you just did a Control-A to select every single cell in the spreadsheet, and you just made them all slightly wider. That's the kind of expansion that we're talking about. Do we technically gain weight when we learn new information if consciousness is material? Not necessarily. Could lose weight, right? Can you speak on what you're currently working on? No. There's a lot of things, but some of them are sufficiently new that I don't want to talk about them for risk of somebody hearing and somebody beating us to the punch. Isn't the axiom of choice foundational in establishing the mathematical framework for quantum mechanics? I don't think so. I mean, okay, so it really depends on, well, so no, not for the axioms. Now, it depends on how you view space-time, but please tell me you believe the Earth is round. Of course it is. Is when quantum mechanics see star algebras? That's one way to view it. Sorry, there's a loud garbage truck. But like, so there are a few, there are axioms of quantum mechanics, which I think they're called, there's a good Wikipedia page that summarizes them. Let me see if I can pull it up. It's not the Dirac von Neumann axioms. It's a different... There's a different Wikipedia article that has it does a really good explainer. Maybe it calls them postulates or something. Mathematical formulation of quantum mechanics. Yeah, here we go. So if you look at the postulates, like the postulates don't necessarily require an axiom of choice. It doesn't require anything, any sets that are infinite, technically, I guess. Right? Any infinite sets they have to put bases on. So, but maybe there's something that I'm missing. I mean, like you could have entirely finite Hilbert spaces, and then you don't really need the axiom of choice, I don't think. I guess maybe you do because you're doing there's an evolution equation that implies some continuity there, but besides that, maybe not. How similar is the Higgs boson to a synapse? Not at all. What do you think of the subsurface? What do you think the subsurface in the middle of the Earth is made out of? Well, I think it's made out of rock and then like hot rock, right? One thing flirts do not understand is just how competitive scientists are. They all want to prove each other wrong, and as a result, the most accurate theory info usually prevails. That's true. Can heat flux influence the viscosity of a fluid? Well, I don't know about heat flux. I suspect not, except insofar as the heat of a fluid, like the temperature of a fluid, can affect its viscosity. Why is gauge symmetry considered a redundancy rather than a physical symmetry? It kind of is considered a... okay, so it kind of depends. Are you talking about a local gauge symmetry or a global gauge symmetry? Because global gauge symmetries are a redundancy. But when you promote them to a local gauge symmetry, that's when they become physical things. That's the kind of the way to think about it. And it's because the local gauge symmetry produces observable things, right? Produces observable effects. Global gauge symmetries do not. Do you think it's possible to use optical tweezers to hold a photon and detune the frequency? No, I don't think so. Optical tweezers use light to hold matter generally, except at very, very high energies, where you can have photon-photon scattering. Generally, light doesn't interact with other light. What's your most cited work that you're most proud of? My most cited work is the first paper that made up my dissertation. It's also the oldest, so I mean, it's most likely, it's like not unexpected that it's most cited. It has like 35 or something citations, or actually no, I'd have to go and double check, but it has like double-digit citations, which, you know, that's a lot for mathematics. How can some infinities be finite? They aren't. Infinities by definition are not finite. How do you know all this stuff? I have a PhD in physics. If possible, what particle would you want to be? I wouldn't want to be a particle. Particles don't think. I always think that the universe expansion is just a weak point on a bike tire that bubbles out, but I'm a simpleton. That's one way to think about it. But then people think that there's like edges and stuff. Is it true that we don't actually touch anything? Not really. It really all hinges on what you mean by the word touch. If by touch you mean like there is a thing that you can't push past, then yeah, of course you touch things. But like particles aren't solid objects, so it doesn't even make sense to talk about like two solid objects bumping into each other, right? By the way, I'm going to shill for myself for a minute. So you guys probably know me a lot from the debates that I do. If you do, and you want access to the debate notes that I have, because I have debate notes for flat Earth, for theism, atheism stuff, for young Earth, for MAGA stuff, all of this debate stuff. If you want access to it, the best way to do it is to become a member on either YouTube or on Patreon. It's like $4 or $5 a month. You can get access to this document that I've been curating for the last 2 years or so. There's a bunch of sources, arguments, facts, counter arguments, and so on that you can find there if you ever want to use them in your debates. So that's the thing that you should consider doing. Or you could just become a Patreon or become a member because you like me. Anyway, let's answer Dill's question. Can matter be created and destroyed? Yes. That is a lot of chemistry, not a lot of physics. If we define matter as that kind of particle or stuff made of particles that take up space, then this is just fermions. Now fermions, things like electrons, protons, neutrons, quarks, neutrinos, fermions can be destroyed all the time. In fact, if you take a fermion and you take its antimatter partner, they annihilate each other, and the two fermions no longer exist. In TikTok, you spoke about the entropy of the universe. I thought you can't do this. So you can talk loosely about it, but if you have to be really, really careful when you're talking about what you actually mean by the entropy of the universe. You could talk about the entropy of the observable universe, for example, maybe if you can treat it in equilibrium, or you can approximate it as being in equilibrium. It's like talking about the entropy of stuff in general is really hard. Doubly so for the universe. Is time a vector or scalar quantity? It's not really either, at least not with respect to any symmetries. We generally talk about vectors or scalars or tensors or whatever with respect to such and such a symmetry. Time is none of those things. Time is a component of, you might call it like a four-dimensional manifold. So it doesn't transform like a scalar or a vector or anything like that. Isn't it energy that can be neither created nor destroyed? That's also not true in an expanding universe or a contracting universe for that matter. Energy is only conserved when the laws of physics, when kind of like the space-time, and when the space-time is not changing from moment to moment, then you can have energy conservation. But our space-time is changing from moment to moment, so you can't have energy conservation. Fears Interaction sends the $5. Thank you so much. Of the quantum mechanics discussions you have on this channel, what percentage would you say are with people that somewhat understand the subject? I don't think I would be far off if I said 0%, which is not great. Can't you call it a component of the position for a vector? Sure, but components aren't scalars, they're not vectors either. And what you would be talking about is the time coordinate for a particular space-time event, but that's not what time is itself. Are you in the Czech Republic? No, not anymore. I used to be. What is your favorite Star Trek series? Oh, it's Deep Space Nine. It's just so good. Flynn Illustrations asks by sending £5 if an inch or two hole was in the ISS, could an astronaut safely cover it with their hand? At what size does pressure make that too dangerous? So look, so I don't know what the ambient pressure is inside the ISS. Ambient air pressure is like 14 pounds per square inch. But we can Google this. I imagine it's slightly lower. Oh no, okay, it's kept at 1 atmosphere. So if the hole is 1 inch, then there'd be 14 pounds of pressure pushing on your hand as you cover it, which is perfectly fine. You will be fine. Now, your hand will probably be too small to cover a hole that would be dangerous to cover. Yeah, I mean, look, keeping air in isn't really that hard. It's keeping high pressure water out that's the hard thing. I hate Deep Space Nine, so boring. It's okay to be wrong. Do you think the fabric of space-time being woven... What do you think of the fabric of space-time being woven together by wormholes? I'm not convinced, but it's something that people are working on, and people are allowed to work on things that I'm not convinced of. Maybe they will convince me at some point. Question, I thought about what the Big Bang, basically a giant black hole, end of its lifespan? No. So the Big Bang and a black hole don't really have anything in common, except that, like, gravity breaks down there. God, that's so annoying. It's just someone walking around outside. How likely do you think that the Graviton exists and it will be detected? Also, suggestion for young Earth creationists, show cave art tens of thousands of years old. So I don't think that the Graviton will be detected anytime soon. I do think it probably exists, but I don't think that it exists anytime soon. Or I don't think that we'll detect it anytime soon. As far as showing young Earth creationists the cave drawings, they will just say, oh, well, how do you know they're that old? And then blah, blah, blah. One moment. All right, sorry about that. Yep, FBI is at my door. At which magnitude does something switch from a quantum to classical system? Are some systems both? So this is not like a hard defining cutoff line, right? The issue is that, oh my God. The issue is that quantum states are very fragile. And so it's easier to keep something very, very small isolated from external influences. And so it's easier to keep small systems in quantum states. However, if you're very, very careful, you can maintain quantum behavior to things that are arguably macroscopic. In fact, this was what the Nobel Prize in Physics was awarded for this year. They produced something that's about slightly smaller than a human hair that was in a quantum superposition, which is amazing. Is the universe expanding uniformly? That's generally a principle that's assumed to be true, but maybe not. Can you explain what the cosmological constant can you explain what is the cosmological constant in relativity? The cosmological constant is this idea that there might just be a feature of spacetime, which is totally fine, like that can just be there. A feature of spacetime that changes the evolution of the universe. It's not matter, not energy, it's not curvature. It's just like an extra contribution that is in the equations, and it's governed by a single number, the cosmological constant. And the way you can model it is as a constant amount of energy present in every, even in empty space, everywhere in the universe. If spacetime isn't fundamental, what are the implications? That there's something else that's more fundamental. WizNilly sends $2. Why is pi in the permittivity of free space? Oh, it's just a convention thing. It's just to make the formulas nicer. It doesn't have to be. Is ball lightning actually real? Well, yes, seems like it is. In fact, it's one of those things that's been recorded for like, or documented in history for like 800 years. So yeah, it's probably real. John sent $5 on Buy Me a Coffee. What's your opinion on Dr. Ian Stevenson's research? I'm asking because it seems a growing consensus among certain scientists that consciousness might be fundamental. I've never heard of this guy. And I'm not familiar of really any physicists who think that that's the case. I'm also not familiar of really any neurologists or neuroscientists who thinks that that's the case. So I don't think that this is a growing consensus, a growing belief among scientists. I don't know who this guy is, though. Judy Bassett sent €5. Thank you for your physics answers. Well, you're welcome. If I push a fiber optic cable at 10 miles per hour while sending light, does the light arrive at c plus 10 miles an hour? No. Light travels slowly through fiber optic cables, right? The reason why fiber optic cables work is because light travels slowly through them. Otherwise, you wouldn't have total internal reflection and the light would just leave the glass, right? Will we ever figure out turbulence? Maybe if we solve the Navier-Stokes problem. Thoughts on the physics of rogue waves? I don't know a lot about them. Maybe I'll make a video about them so then I can learn more about them. What are your thoughts on about the WOW message from space and the tech-based comet outside our galaxy? What? So the WOW message has been incredibly solved. Like the best explanation that we have for it is that it was a microwave laser, a natural microwave laser that happened as a result of perhaps a nearby supernova, or like a nearby detonation of some kind that excited a gas cloud and caused a maser to be shot out towards us. These are things that do happen. It's just that this one was aimed at us, I guess. I'm not sure what tech-based comet you're referring to, but 3i Atlas didn't originate from the same location as the WOW message anyway. Would it be okay if I invented unlimited energy? Yeah, please. J. Owen Full with the $2 says, I filled out the form on your link tree. Thank you. Okay. I'm not going to get to it now, but yeah, but okay. Can you solve dark energy here right now? Nope. No, it can't. If the universe is expanding uniformly, aren't the means of detecting it equally expanding? No. So the idea is that it's expanding uniformly as in it's expanding by the same amount in each direction, but that doesn't mean that there is expansion everywhere by the same amount. The general view is that it's expanding in places where there isn't matter, basically. And there's a good way to understand this. OR says that consciousness is fundamental and it's championed by Penrose for one. And did you miss the Blitz of tubuline superluminal occupation studies? If so, just say, I'll send you the link. So Penrose, I don't think that Penrose says that consciousness is fundamental. Penrose says that consciousness is quantum, not that it's fundamental. And yeah, Penrose is one physicist, and he's generally kind of kooky in this regard, but he's brilliant, so we give him a pass. I would be very surprised if you sent me any evidence of superluminal anything. But But yeah, send me stuff. Sure, I guess. What game has the most realistic physics? Kerbal Space Program. Next question. It's just so good. Is dark matter the beginning of another universe or something we haven't discovered yet? Dark matter is just a kind of stuff that we can't see. What is a neutrino? A neutrino is like the cousin. It's like the antisocial cousin of the electron. It has very similar properties to it, except it just doesn't have charge. And so it doesn't interact in the same way that electrons do. What does that mean, consciousness is quantum? You'd have to ask Penrose. Charles sends $5 to ask, have you ever seen the film Primer? Thoughts on how they treat time travel? And part 2, what about Interstellar? So I haven't seen Primer, so I can't comment on it. But Interstellar was a good movie up until the last 15 minutes or so. And then they went off the rails with like the whole like Tesseract and all that stuff. If consciousness is fundamental, can you give what implications that would have for the rest of physics? I don't think that that would be physics at all. I don't know if there'd be any implications. Yeah, I don't know. Is the possibility of a big rip something you could think could happen? It seems like that's not on the table anymore. Do you recommend any mods for KSP? I used a lot of mods. Principia is a good one. I don't know if it's still... I haven't played KSP in a long time. Does a double slit experiment indicate that the universe is composed of information? No, it doesn't. Did you understand most of what was happening in Oppenheimer? Yeah, I did. It was a cool movie. They actually did a pretty good job with the science too, but that's like historical stuff, so. What are your thoughts on the Hubble tension? I'm hoping this new study that suggests that the universe is not accelerating in its expansion, but decelerating in its expansion. I'm hoping that this new study helps resolve that, because that would be really satisfying. Do video games use physics? Yeah, just not very complicated physics usually. So phantom energy isn't thought to be anymore. Yeah, basically. It's at least like dark energy, at least with recent data, seems to be getting weaker. And that would mean that it's not phantom energy, it's some other, it has a different equation of state. How many years did it took you to become a physicist? Well, I went to 4 years of undergrad, then I did a straight to PhD. The first 2 years are basically a master's, and the next 5 years I did as a PhD student. Double slit indicates like observation can have a causal effect. It doesn't do that. What was the hardest undergrad math course you took? Well, I took topology as a freshman, and that was a mistake, and so I withdrew from the class because I bombed on the midterm. I just wasn't ready for it. If the early universe stretched like a living membrane, leaving quantum striations across space-time, can we say that reality itself is the echo of those first vibrations? I don't know what that question means. First it's expanding, now it's not, so basically I haven't a clue. No, it's still expanding. Nobody said it's not expanding. It's just not accelerating in its expansion. And these are things that are hard to measure. There's a reason a Nobel Prize was awarded for discovering that the expansion was accelerating. I'm trying to get something published. I need you to review. Will you help? And I don't endorse randos on the archive, sorry. Is physics my passion? Yeah, you could say that. Is there a significant difference between neutrinos, positrons, and electrons besides the charge? Nope. I mean, they have different masses, but no. Do physicists use Python? Well, I do. I know a lot that do. Are tachyons real, and if so, how do they work? We don't really have any evidence that like tachyonic particles exist. Tachyons in quantum field theory are usually used to describe a kind of instability. So you'll have something called a tachyonic instability, and the Higgs boson underwent such an instability, and as a result had something called spontaneous symmetry breaking, which gave rise to mass in the particles that we see today, except the neutrinos. You don't endorse randos, but I'm asking you to review. No, so like I'm not going to endorse somebody that I don't know personally. Like it's just not going to happen. I also have a policy of not reviewing theories that people send me, because otherwise I would never have any time to do anything. So like I just don't have the time. Like that's a huge time commitment that you're asking me to do. It's not something that I can do. Will the center of the universe compress right before the big crunch starts? Oh, the center of the universe, there isn't a center of the universe as far as we can tell. Can you explain Maxwell's equations? Thank you so much. Yeah, so Maxwell's equations, are the equations that describe electricity and magnetism and their unification. And they describe these phenomena in terms of electric magnetic fields. So you can think of fields as like, I need to figure out a good way to explain this to a layperson. A field, at least the electric field, you can think of as what direction, it's like a direction and a size associated with a point in space, and it's what direction and how strong a particle would move in as a result of the electric force if you put a particle at that place. So what Maxwell's equations do is they tell you what shape these fields are based off of what charges are present, because charges cause electric magnetic fields, how those charges are moving. That's what Maxwell's equations do. Is math equally important as physics if I want to become a physicist? To an extent. It depends on what kind of physics you want to do. If you want to do theory, then yes, absolutely. If you want to do experimental physics, then not as much. Power going into a transformer at 25 kilovolts, coming out at 120 to 240 volts. Where do the volts go? Volts aren't conserved. Now, the power will be conserved approximately. There will be some losses. But what you'll see is that the current on the output is way higher than the current on the input. So voltage goes down, current goes up. That's what transformers do. When do you think we will discover element 118 on the periodic table? Oh, we already did. It's already named. It's called oganesson. Oldest person you've seen become a physicist? I think he was in his 50s, but I don't know if he became a physicist or if he just finished his PhD and then left. Do you believe in the Big Bang Theory, and if so, do you feel it violates the first law of physics? I don't know what the first law of physics is that you're referring to, but no, the Big Bang doesn't violate any known laws of physics. Is there similarly not an edge of the universe? Yeah, that's the idea. Why can't perpetual motion exist? So essentially, because everything gives off a little bit of energy whenever anything moves. So you'll always lose a little bit of energy. Mellow Matt sends $5. Though both are difficult, would you say future time travel has more probability than past time travel? Future time travel is not difficult at all. We're doing it right now. Future time travel is super easy. Past time travel seems impossible. First law of physics, don't talk about physics. True. Thoughts on Bob Lazar? He's a hack and a fraud. What's your favorite irrational number in physics? I don't know if I have one. Pi is pretty good though. Explain what a spinner is. A spinner is a thing that takes 720 degrees for it to rotate back into itself. At least that's one way of thinking about it. Thoughts on 3i Atlas? It's a comet. That's cool. It's an interesting comet. Not all transformers blitz. Some decrease voltage or keep the same. Well, yeah. So transformers trade voltage for current. That's what transformers do. That's why they're called transformers. Please explain Cherenkov radiation. Yeah, so Cherenkov radiation is to light as sonic booms are to sound. So if you fly through the air faster than sound can travel through the air, all of the air molecules that jiggle around and usually form sound, they kind of get stuck at the front of your plane. And so they bunch up and you get a huge loud sound right at the front of your plane. And that's what a sonic boom is. Now, similarly, if you have a charged particle moving through something faster than the local speed of light, remember, light travels more slowly through water, through glass, etc. If you have a charged particle moving through there faster than the speed of light, it's going to, now, faster than the speed of light, and, yeah, if you have a charged particle moving through a substance faster than the local speed of light, then all of the electromagnetic distortions that come from this charged particle moving through it, because that's what charged particles do, they would all bunch up. And so you get bright flashes of light, usually bluish, coming off in like a, kind of glowing from this particle moving through this object faster than light. It's like a photonic boom, if you will. Akshay Singh sends 100, I think these are Indian rupees. Do we use higher order differential equations in physics? And if yes, where? So second order is like the standard, but occasionally higher order things pop up. For example, I wrote a paper 4 months ago. It's almost 4 months ago now, so we're waiting for peer review. A few months ago anyway, that invoked a type of fundamental particle whose equation of motion is a fourth order differential equation. And that's just how that particle behaves. So yeah, sometimes, just rarely. Thistle Honey sent a star map of Polaris. Thank you, Thistle. I appreciate that. Why is 1 mole 6.0221407 times 10 to the 23rd? That's just how we defined it. Are you afraid to answer some of these questions? It does seem like it. There are just a lot of questions, so I have to pick and choose which questions I'm going to answer. How's M theory going so far? I haven't really been keeping up with it. I never really fully understood it, I don't think. Is change in the speed of light instantaneous when it enters or leaves? And leaves glass? Yeah, sort of, but you can't think of as light as like a point particle. It's a wave. And so what you're going to see is just a boundary condition between the waves. I mean, think of it this way. If you took a thin string and you glued it to a thick string and you put them both under tension, the waves, and then you pluck the thin string, it will have a wave that travels along it at a different speed than the same wave once it transmits through to the thick string, and that transition will happen instantly. Does light have acceleration? No. How can topology explain or describe the structure of singularities inside a black hole? We don't even know if singularities exist, but you can talk about singularities in a manifold as being a puncture, and punctured manifolds are described topologically. You can talk about winding numbers around them, you can talk about holonomy, you can talk about homotopy, you can talk about all sorts of things as far as like a puncture in spacetime goes. However, a lot of people don't think that singularities exist, so there would be no interesting topology happening there. Are there any other sources of income for physicists besides research and teaching? Not really. By the way, if you spam your question, I don't want to answer it. I won't want to answer it at all, so don't. Can you have a nonlinear mass in E equals mc squared? I don't know what you mean by nonlinear mass. The equation is linear in the mass, so like that's just what the equation is, right? Mellow Matt sends $5 to ask, 2 quantum particles that are entangled are separated and one falls into a black hole. Are they still entangled? You would never be able to, in fact, you can never know if something is entangled from a single particle. You just can't know. It's impossible to know. And so this is a really interesting question. It really depends on what your understanding of the resolution of the black hole information paradox is. So if you think that firewalls exist, then the answer is no. If you think that firewalls don't exist, then the answer is probably yes. Blitz, are you going to remind Ian 2 to the power of infinity isn't infinity? No, but I will remind you that 2 to the power of infinity isn't a sensible question to ask. 2 to the power of infinity isn't a well-defined set of symbols. So I thought all particles within a field were somewhat entangled. Well, yeah, so the question is how much entanglement there is. So why did he give an answer? Because he was addressing a lay audience. You know this. Yeah, exactly. Infinity is not a quantity. So what you can ask is you can ask, what is the limit of 2 to the x where x approaches infinity? That's totally well defined. And you can say that it's undefined, but to a lay audience, you would just say, oh, it's infinity. And that's like a reasonable thing to say. In fact, you might even say that to like college undergrads, because things like words like undefined are kind of tricky if you're not familiar with the mathematical jargon. The Mad Cow sends $5. Do you think the geometry of spacetime is caused emerges from the quantum fields, not undiscovered fields? Maybe. I'm not so sure. I'm pretty agnostic about whether spacetime is emergent. Are you a good cook? No. Dude, have you seen the hyperbolic quantum mechanic Pluton combobulator? Yeah, I have. What would happen if we were ever able to split quarks? Well, then we would have discovered something new. If light speeds up when leaving glass, where is the energy coming from? Or is that a dumb question? The energy is conserved. It's the same amount of energy. The frequency is the same. And the energy of a photon is, or the energy of an electromagnetic wave is what its frequency is. It's just that the wavelength changes. And because wavelength, frequency, and speed are related, the speed changes. How far is the leap in difficulty from a master's to PhD in physics? It's not that it's not that there's like a difficulty change. It's not like you're taking harder classes. It's just that it's a different kind of set of tasks that you have to do. You're not doing homework. You're not, you know, studying for exams. You're trying to do original research, which is just a different style of thinking, and it's hard. Have you played Kerbal Space Program? Yes. Why is symmetry so important to physical sciences? Well, you can blame Emmy Noether for that. Her theorems in the early 1900s basically proved that conservation laws arise from symmetries. And so, you know, we care about conservation laws because they're useful for making predictions. And if those things arise from symmetries, then symmetries are super important. Sean F. with the 14 Canuck bucks. Thank you so much. ACS Publications, the Journal of Physical Chemistry, B volume 128, issue 17, article Ultraviolet Super Radiance. Okay, let me type this in. Ultraviolet Super Radiance from Mega Networks of Tryptophan. Oh, I've read this. There's no superluminal stuff. I don't think that there's anything superluminal in here. Super radiance and superluminal are very, very different. Superluminal means faster than light. Super radiance means that more energy is emitted than what you would expect, say, classically. But that's not superluminal. And I understand that like the words are similar, so like I can understand the confusion. No, I know it's a hard one, but it's the most interesting question you could answer. What's the least well-supported physics theory that you nonetheless think will be shown to be accurate? I think that I mean, it is supported, but I guess it's not. I guess it's new. I think that the cosmological constant is 0. I don't think that there's a cosmological constant, or at least I don't think that there is an effective cosmological constant, which is part of the Lambda CDM. It's part of the standard model of cosmology. Based on the Nobel Prize, do you think we could get large systems to exhibit more quantum properties? Yes, people are working on this. Yeah. I've heard that you can test the speed of light in a microwave. And understand a bit about magnetrons and constituents, but how do you test the constant with a household microwave? Yeah, so the point is you can figure out, essentially with like an oscilloscope, what the frequency of the microwaves produced by your magnetron are. So magnetrons oscillate at a particular frequency. You can figure out that frequency by looking at the electronics. And then, in principle, you could even calculate it, but that'd be a pain. And then you can put like a chocolate bar in the microwave, and you can measure the distance between places where it's melted. So like microwaves have standing waves that form in them. That's why they rotate. But if you take out the rotation wheel and you just put a chocolate bar somewhere, a big enough chocolate bar, there'll be parts where it's more melted than others, and you can measure the distance between those parts. And that will give you the wavelength. Actually, that'll give you half the wavelength of the light wave that's bouncing around inside your microwave. And once you have the wavelength and once you have the frequency, you can multiply them together and get the speed of light. It's super cool. What is driving the rise of anti-intellectualism? I don't know. Do you think it's possible we are the second wave of humans on Earth? No, I don't think so. 3i Atlas, thoughts on it? It's a comet. It's a neat comet, but it's a comet. Is space-time continuous? Why is GR incompatible at smaller scales? We don't know if space-time is continuous. I'm pretty agnostic about it. And it's not that we predict that it's incompatible, but we've never like made a measurement that shows that like GR gets something wrong at the microscopic scale. This is just something that's kind of expected based off of like how GR behaves and how like small scale quantum mechanics behaves. What kind of technological or scientific advancements would come if we ever solved string theory? I suspect none for a very long time. It's really hard to say though, because the kinds of like when electrons were first discovered back in 1898, I want to say, nobody had thoughts that like this would be like useful. Like, nobody had ideas about this. In fact, and yet they're now used all the time. We have like electron microscopes. Similarly, when it was discovered that light is an electromagnetic wave, nobody had any thought that this would be useful. In fact, famously, Hertz, the famous physicist, I forget his first name, Dr. Hertz, Professor Hertz, said that, oh, it's just a curiosity, it won't be useful for anything. So like that's very, very, like it's, these kinds of things are very unpredictable. Neurolancer sends 7 Canuck bucks. If you think lambda equals 0 in Lambda CDM, what's your hypothesis theory for the expansion of the universe? I don't have one, but I think that there's good reason to think that you can't have a cosmological constant. And I think that our data Heinrich Hertz, there you go. I think that the data that we're seeing in the last few years coming out from the DESI collaboration, coming out from this recent paper, kind of just shows that, yeah, our observations are not consistent with cosmological constant. Yeah. Canuck bucks, yeah, of course, they're Canuck bucks. What do physicists study? Is it only mostly math? Physicists study physics. So physics is a field that studies things like matter, motion, forces, waves, these kinds of things. That's what physicists do. What is lambda? Lambda is the cosmological constant in general relativity. Is it possible to fire a strong enough laser to fry a human? I mean, I guess it's in principle possible, but like, we can't do that yet, I don't think. Yeah, we won the war. We'll call them Canuck bucks if we want to. There you go. What are your thoughts on block universe model? I think it's correct. Can you go for physics if you don't understand it? Well, hopefully you would understand it by the time you finish the degree. How is physics helping in quantum breakthrough? Any new research? All quantum breakthroughs are physics. God, my stomach is really rumbly. Mellow Matt sends $2. My friend showed me quantum immortality. Is it BS? Yeah, kinda. I have a video on it from a while ago that might help. Also, Sean Carroll has a blog post on it, which also might help. Is Planck length affected by Lorentz contraction? The Planck length is just a constant. It's just a length. It's just like how the speed of light is like a constant. Planck length is just a constant. It's just a certain amount of distance that you can measure, the smallest perhaps. Would it be groundbreaking if we reconciled quantum gravity? Yeah, of course. If we wanted to land on Titan, what kind of gravitational effects would we need to overcome from Jupiter? Oh, I don't know. But I suspect that Titan's local gravity is strong enough that we could have, that it wouldn't really be an issue. In fact, you could probably use Jupiter's other moons to basically enter the Jovian system, which is what the Jupiter's lunar system is called, to enter the Jovian system and basically land on Titan for free would be my guess. Can you discuss the Kerr-Newman metric? Please explain how does a black hole possess electric charge? Well, look, if you have a black hole and you throw an electron in, that charge doesn't go nowhere. And so the black hole has charge. And that's going to affect the curvature of space-time because, as we know, electric charges produce electric potential energy. And electric potential energy curves space-time. So it's going to affect the space-time. Have you watched The Expanse? If so, what do you think of it? I only watched maybe the first third of the first season. I couldn't really get into it. Advice on how to build a good work ethic? I don't know. I don't even know if I have a good work ethic. What kind of energy would be needed to destroy matter? It's not really an energy thing that, well, okay. Like if you shoot a particle beam at stuff, some of the matter will definitely like blow up and turn into other stuff. What do they call it in physics when the photoduplication reaches saturation? That's right at the point they say it's in what? They say it's in a superluminal state. I don't know what that question means. Does the speed of light reduce in certain mediums? Yes, in every medium except empty space, the speed of light is lower. Do physicists write in LaTeX? Absolutely, we do. How many years do you think it will take until quantum computers hit the market? It's not clear if they ever will. Would a laser be considered a particle beam? Yeah, sure. It's a beam of particles. Did the recent discovery of James Webb of distant galaxy hurt Big Bang Theory? No, not really. Not at all. Do you believe only the present time exists, or is time multidimensional? Time is one-dimensional, but the entirety of space-time exists, at least as far as, you know, general relativity is concerned. Oh, I should take a minute and chill for myself since I haven't done that in a while. So first of all, if you guys are watching, I hope you're enjoying. There is a Discord server that you can get access to. It's free as long as you're 18 plus. Go ahead and join the Discord server. You can ask me questions. You can talk with like-minded people. I send out announcements there all the time. I really need to automate that, but I do it anyway. Also, if you want to support me and you want access to my debate notes, which, you know, I basically use as like references for resources and things like this, Then you can either become a member on one of the 2 YouTube channels. It's like $4 or $5 a month, or you could become a Patreon member at any level. I think it's like the lowest one is $5 a month or something like this. And then you get access to the debate notes, which a lot of people seem to appreciate. Third and final thing that I should shill for myself, make sure to go subscribe to the 2nd channel on YouTube. It's called Dr. Blitz Debunks if you haven't already. I'm trying to get that channel to grow because that's where all the clips from the debates are going. And I'd like those to get more eyes on them. So the more subscribers we have, the more people it will be sent out to. And who knows, maybe you'll like the videos. So make sure to go do that, and I'll go back to answering questions now. Why are the first 7 days of the week always the hardest? Great question, man. Are you worried about the state of physics research funding in the US? Absolutely it is. Is it true that no one understands quantum mechanics? No, lots of people do. 0-point energy, has there been progress towards it? It's not, 0-point energy is pretty well understood at this point. I don't know what kind of progress you're hoping for. It's like a thing that is predicted by quantum field theory. Why do negative energy virtual particles tend to fall inside the black hole more than positives? It's that, so in the virtual particle model, which by the way is just like a helpful way to think about it, it's not actually what happens. You have 2 particles pop up. One pops up slightly inside the event horizon, the other pops up slightly outside the event horizon. And by the nature of being inside the event horizon, is forced to have negative energy. That's the only way that you can pop a particle into existence when it's inside the event horizon. It has negative energy. And the one that outside the event horizon has positive energy. So this is just a feature of the virtual particles that pop in and out of existence. They have to do that. What would quantum computing solve in the physics field? Not a lot, as far as I know. What do you think about the zero energy universe? I'm not sold on it, but it's an interesting idea. Just by looking at you, I know your political leanings. Because I'm wearing glasses? I mean, if that's true, cool. Can you explain negative energy? If you know what negative numbers are, then you know what negative energy is. It's that. How hard would it be to broadcast a shield of radio waves from an array of drones so battlefield drones can't be jammed? I don't know what a shield of radio waves means. Radio waves aren't like a wall that can block out other radio waves. Radio waves just add to each other. Yeah, so I don't think that's a thing. Brissinger Blaster sends $5 to ask book suggestions for a layman to get started learning physics. Yes. Well, okay, it depends. If you just want pop physics, this is the book. This is the book, A Brief History of Time by Stephen Hawking. It's the GOAT. It's a bit outdated. It's like 30 or 40 years out of date, but it's still wonderfully written. You just have to keep in mind that some of the stuff that's mentioned is not really believed to be true anymore just because, you know, we have better and new data. If you're looking for a textbook, probably the one of the best textbooks around is, like, if you want just like a university textbook, pick up University Physics by Young and Friedman or by Sears and Zemansky. Those are standard undergrad first year physics textbooks, and they're quite good. Microtubules, tubulin as a quantum computing substrate. Yeah, okay, that doesn't have anything to do with superluminal stuff, right? There's nothing superluminal about that. Do you recommend getting into academia after a physics PhD? That's like what most people do. Well, okay, that's not true. A lot of people want to get into academia, but you'll make more if you go into industry, and you'll have an easier time finding a job if you go into industry. How long have you been YouTubing? Did you start with shorts or videos? So I started on TikTok. I started on TikTok in May of 2022, so 3.5 years. I started on YouTube fairly recently. I upload my TikTok shorts to my main YouTube channel at Blitz PhD, and I also do debates, which again started on TikTok, but I now also stream them on YouTube. The debate stuff goes on the Dr. Blitz Debunks channel. Yeah, if you stay in academia, you have to do it for the love of the game. Absolutely. Was the book Gravitation useful? Do you mean the one by MTW? The Bible, if you will? Because Gravitation is by MTW, right? Never remember the names, I just remember the authors. Yeah, Gravitation's MTW. It's MTW is a great reference book, but it's a slog to get through. What kind of industries employ physics PhDs? Semiconductor, fabrication, stuff. It depends on what physics you do. Are gravitational waves real? Yeah, and they've been detected ever since 2015, which is like a huge deal. Do you think we can generate gravity waves in the future? We already can, just move things around. Is repulsive gravity possible? Yeah, that's what dark energy is. At least that's the idea. What do you think of physics lectures by Richard Feynman? I never actually used them. And keep in mind, they weren't actually written by Feynman. They were kind of summaries of lecture notes that Feynman was giving live, and then somebody else wrote them down. But they're generally regarded as pretty good. Who's on your Rushmore of physics? Einstein, Newton, Rutherford. Maxwell, maybe? No, I feel like you have to have like either like Bohr maybe, or maybe Planck, or maybe maybe Schrodinger, Heisenberg. There's a lot. There's a lot of like a lot of the early quantum physicists. They all are like really spectacular, but there's just a lot of them. What do you think of Fritz Haber? Well, he invented a really useful process for producing like ammonia, I think, for like fertilizer, but he also invented mustard gas or chlorine gas or something. So, you know, mixed feelings. They're all chemists. Heisenberg's what? We don't get relativity without Planck. That's not true. That's not true at all. Bro, can you explain angular impulse and your thoughts about the book, i.e. Iridov? I have no idea what that is. Do you believe in any conspiracy theory related to your field of research of science in general? No. I'm about to finish my master's. Should I do a PhD? I don't want to work in academia. I want in industry. Then you might not need it. The only reason you do a PhD is for the love of the game. You'll be fine with a master's if you want to go to industry. 3i Atlas, your take on it? It's a comment. Can you explain quantum angular momentum? It's utterly baffling for me. Look, this is a lot like quantum. It's a lot like charge. It's just charge is less unusual for some reason. Angular momentum is just a property that a thing can have, just like how charge is a property that a thing can have. And they're intrinsic properties. You can't break up the charge of an electron, just like how you can't break up the spin of an electron. Mr. Kreinen, I don't appreciate you spamming. Please stop spamming. What's the biggest physics idea that was overturned by new data? Well, I would argue Lambda CDM was overturned by the DESI collaboration, which was the standard model for cosmology. But that's not like scientific consensus. It hasn't been like agreed upon that it's you know, been overturned yet. Am I gonna have to mute you, Mr. Kreinen? Like, stop spamming. No spammerino in the chatterino. Just wandering in our galaxy forever with the only goal of spreading life to other planets. Well, I don't know. Did you find academic work? Well, I'm still doing academic work. And, you know, I will see if I get a job offer at the place I interviewed last week. I'm a physics student, but finding math difficult. Any trick to overcome this? Practice. It's just practice. Tenure job? No, it would be a visiting assistant professorship. Your stream videos are going to get a lot of traction and end up being your income. They already do. They already are my income, but hope you're, oh, I missed that. Is it true that Wall Street poaches physics PhDs for quant finance? I don't think that that's true anymore. Is there a foreseeable end to discoveries in particle physics? Not that I can foresee. Do you wish to become a professor? Yeah, that'd be good. What job a physicist do? I mean, it doesn't show in the economy. I mean, there's no business happening in it. That's like asking what job does a chemist do? Like a chemist who does basic research. So physicists produce knowledge. Knowledge is useful for producing technology, useful for producing, better educated citizens, etc. So physicists produce knowledge. That's the product that physicists make. Did my friend respond to your email, or his word spread far enough for someone to reach you? What? I don't know who you're talking about. Do you have anything published, and if so, what? Yeah, I have like more than a dozen papers published. I just don't like to share them because then people will dox me. I mean, they wouldn't be doxing if they just had all of my info, which is in the papers. Are wormholes stable enough for potential travel? Not as far as we can tell. What's the most expensive experimental equipment you've ever handled? I don't know. It was probably something in undergrad. I'm not an experimentalist. What's your opinion on Roger Penrose's theory of consciousness? I think he's a little bit kooky. Where should I publish my modified theory of gravity? Send it to a journal. Send it to Classical and Quantum Gravity. It's a pretty standard journal for this kind of stuff. Will time travel ever become reality? We already are time traveling to the future. What is the difference between a theoretician and an experimentalist? Well, it's kind of in the name, right? A theorist comes up with, does like theory stuff. They like make predictions, they produce new models, they analyze data or they take old data to try to, come up with new ideas. Experimentalists design and conduct experiments to test ideas, to try to collect that data that then goes to theorists. How long do you think it will be until we become a type 1 civilization? I don't know if we ever will. I also think that the type 1, type 2, type 3 stuff, I don't think that that's like a useful metric. Where should I send my proof that the Earth is flat? To the Nobel Prize Committee. In your opinion, how likely is it that the fourth dimension is time? Because I've thought about it from an extremely amateur perspective, I have my own thoughts. Yeah, so in relativity, space-time is four-dimensional. You think a theoretical physicist should be excellent at problem solving, like problem sets? Well, yeah, kind of, because that's what the job sort of is. Angelo Garuso sends $10. What would happen if two magnetars came within magnetic field range of each other? Would they merge like black holes? I guess it would depend on like the orientations of these things, right? Not all magnets attract each other. Some magnets repel each other, for example. So I think it would really depend on the dynamics. But that's like a really, really, really complicated system to model. Like so complicated. You have an interview recently. How did you do? It went all right. We'll see. We'll see if they offer me a job. If they don't offer me a job, then apparently it didn't go well. We'll see. Why'd you choose your field? Because black holes are cool. They're so cool, man. Is the universe finite or infinite? How did scientists figure it out? We just don't know at this point. What do you think about the unifying field theory and how hard is solving it? So I don't think most physicists actually think there is a unified field theory anymore. There was a lot of attempts to do this back in the 80s and 90s and early 2000s, and then it's just kind of been ruled out. Well, not ruled out, but it's been kind of like put on the back burner because none of the attempts have been successful. Do you think that we'll ever reach a point when we can't really discover anything new? I don't know. when it comes out as Hawking radiation, will the other electrons whose quantum entangled also change? Quantum entanglement is only broken when a non-unitary thing is done to one of them, right? What are your thoughts on the Great Attractor? Yeah, it's probably just a bunch of galaxies on the other side of the galaxy. So we're on one side of the galaxy over here. There's a whole big thick disk that we're on one end of. And then on the other side of the galaxy, we're being pulled in that direction. So we can't see through our galaxy because there's stuff in the way. But there's probably just a whole bunch of galaxies over there. Why don't stars have accretion disks in the same way black holes do? They did, and then they formed planets. Do you think you're more capable and intellectually honest than Isaac Newton, who believed in God? I don't think I'm more capable than Isaac Newton. More intellectually honest? Yeah, maybe. Do electricity and magnetism EM fields also curve spacetime? Yes, they do. How do we get pictures of the Milky Way if we're in it? We don't have any pictures of the Milky Way. We can like map out the stars in the Milky Way and then like generate what the Milky Way would look like based off of that mapping, but we don't have any pictures of the Milky Way. Angelo Grusso asks, for $5, how do you create the models of larger complex systems like the magnetar encounter? You'd have to ask computational physics. Like computational astrophysicists are really good at this kind of stuff. That's not my field. I have no idea how they do it. There's actually a good one on here. Her name is, actually she's on TikTok. I don't know if she's on YouTube. Her name is Space According to Skyler, I think, on TikTok. And she's a computational astrophysicist. And she's really, really good. She makes good content. She's a grad student. She's graduating soon. And I respect her a lot. So, yeah. Do you have a degree in anything? I have 4 degrees, 3 in mathematics, 3 in physics, 1 in mathematics. What's the name again? Her name is Skyler. And let me see if I can pull up her TikTok username just so then I get it right. Yeah, it's Space According to Skyler, no spaces. What do you do for fun? Mostly video games. Space according, yeah, okay, I already answered that. Will we ever get a physical object to move within even 1% of the speed of light? We have particles, they're physical objects, that are moving within like a fraction of a percent of the speed of light in particle accelerators. Why are we putting billions to discover space when we can almost nothing about what we have here in depth oceans or deep in the ground? It's easier to get to space than it is to hang out deep below the ocean. That's why. Could the Cassiopeia A supernova potentially help in the formation of planets? Yeah, maybe. What's your thoughts on global warming? Is it a hoax? It's not a hoax. It's real. Very real. Please explain how Willow chip works. It's just a bigger quantum computer than other quantum computers. And I do have a video on it, so you should check that out. It's kind of involved. Does Earth gain weight? I mean, it gains weight, it loses weight. If stuff lands on Earth, then it gains weight. If stuff leaves Earth, then it loses weight. Do you enjoy science fiction? I haven't read science fiction in a long time, but generally, yeah, I do like science fiction. Are there any challenging theories to Einstein's E equals mc squared? No. What's the solution for chronic procrastinator? I don't know, man. I do it too. I have a paper that I have to review, that I agreed to review, that's due in 5 days. So, oh, I should hydrate. Good point. It's due in 5 days and I haven't started. Might have to ask for more time. Information is destroyed inside a black hole. What becomes of information after it's destroyed? It's not clear if it's destroyed. In fact, I would say that most physicists probably think that information is preserved. Do you think it's plausible that we're already inside a black hole? No, I don't think so. How long does it take to review? Well, the paper's like 30 pages or something like this, but you have to review it like really carefully. Like you have to check the math. You have to go through each step and make sure that everything's fine. You have to go through all the arguments. You have to check the references and all sorts of stuff. Like it's a really involved process. That's why peer review takes so long. I had a paper that only recently got accepted and we submitted it in August of 2023. It took them 9 months to get us a review back. And then, you know, we got the review back. There were some changes that we had to make, so we took 6 months to fix those changes because there were some serious changes. We sent it back. Then it took them another 6 months to get it back to us saying, okay, yeah, this fix is fine. Here's some more change. It's just really, really involved, and it takes a long time. How long did I have? Oh, I had like 60 days. I've just put it off. What's your opinion on Wiltshire's timescape model of cosmology? I'm not convinced by it. It relies on this phenomenon called cosmological inhomogeneity, which basically says that like gravitational stuff doesn't really average out nicely. And I think that there's good reason to think that it does. Angelo Garuso, welcome to the channel. What's the probability that fusion will be financially feasible in the next 10 years? I think that's probably pretty low, maybe 15 or 20, but do you think anyone can pursue physics, or it's just not meant for some people? It's hard, right? So once you're 18, a lot of the way that you think, a lot of the skills that you have, a lot of your brain structure, even though it's not like solidified because neuroplasticity is the thing, a lot of that stuff is pretty hard to change. So if you don't have the right upbringing, if you weren't exposed to mathematics from a young age, if you weren't, you know, if you didn't have interest in science fostered in you at a young age, it's just going to be more of a struggle. Now, that's not to say it's impossible, but it definitely will be more of a struggle. And Nectu, thank you for sending a gift membership. I appreciate that a lot. Are your parents in academia? No. Goat physicist? It's Einstein. It's Einstein, easy. Easy cap. How do you think the universe will end? I don't know. All right, y'all. It's been an hour and 45. I am going to lose my voice if I keep going for a long time. So I'm going to end the live here. There will be another Ask a Physicist live tomorrow. But before I end the live, make sure to go consider becoming a member on either YouTube channel or on Patreon. If you do, you get access to my debate notes, which have a whole bunch of resources for all sorts of debates. A whole bunch of arguments, counter-arguments, facts, pieces of data. So super, super useful info. Also, make sure to join the Discord server if you're 18 plus. Cool place to be. Lots of cool people there that you can ask questions. You can ask me questions. So do those things, and I will see you guys tomorrow for more Ask a Physicist. Take care, everybody. Oh, wait a minute. No, before I go, hold on. I got to make sure that there are no cash apps or anything. Okay, there are no cash apps. Okay, we're good.